Hello everyone. In this video, we're going to solve this problem. It's a very interesting problem on sequences. People who are studying elementary real analysis course will face this problem. These types of problems are very common, and to solve, we first need to look at how the sequence is spread on the real axis, because when we see that, we can determine if it's increasing monotonically or decreasing monotonically. If that happens, we need to find an upper bound for increasing sequence and say that the sequence is hence convergent. And if it's decreasing, we need to find a lower bound. Then you can say again that sequence is convergent. If we cannot do any of that, we need to just show that the sequence is a Cauchy sequence. And if it's a Cauchy sequence, it is convergent using a result, right? And then we can just say that the limit of un plus 1 or the limit of un equals L, some real number, and we can just solve for L and find the limit directly. So this is what we're going to do. So let's start, and we can see that un plus 1 equals 2 plus 1 over un. This relation is the most important thing. This will help us find all the values and find a relationship. So we can say that un plus 2 minus un plus 1. Let's solve this one. This is 2 plus un plus 1. That's the value of un plus 2 minus 2 plus 1 over un. That's the value of un plus 1. This becomes 1 over un into un plus 1 into un minus un plus 1. Yes. So now we take the modulus on both sides. We say un plus 2 minus un plus 1 equals 1 over un into un plus 1 into modulus of un plus 1 minus un. We did this because we want to create a pattern, and definitely all these values of un plus 1, u1, u2, whatever you take, they're all positive values, right? And now we're going to create an inequality. We can see that u2 equals 2 plus 1 over 2, which is greater than 2. We can see that u3 is 2 plus 1 over u2. Because u2 is a positive value, 1 over u2 is also a positive value. So this is also greater than 2. Hence, for any n greater than 1, strictly greater than 1, un is greater than 2. Because when n is equal to 1, un is what? Equal to 2, right? So we can say that for two values, un and un plus 1 multiplied with each other, this multiplication is greater than 4, implies 1 over un into un plus 1 is less than 1 over 4. So we put this value here. We say this is less than 1 over 4 multiplied by un plus 1 minus un. Now this is a fantastic thing. We're going to use a result. We know, we say if un plus 2 minus un plus 1 is less or equal to c into un plus 1 minus un for some c belong to 0 to 1 open interval, then un is a Cauchy sequence. Now, it is very important for all of us to understand what that means. Because it is a Cauchy sequence, we can say that this entire sequence that we started with, the given sequence in the question, it's a Cauchy sequence, and hence that sequence is convergent. So we can solve it now easily. Hence, the given sequence is also convergent, right? Please look up this property and see the proof. Okay. Now this convergence will give us that the limit equal to some L, which is a real number, of course. And we can conclude that un plus 1 equal to 2 by 1 plus un, and we can take limit on both sides because they all exist, right? Sorry for the mess. This, yeah. I hope this is understandable. And this will get us L equals 2 plus 1 over L. And this will get us L equals root 2 plus minus 1. When you solve it, you will get it. So now we can see that all the values of the sequence, if this is a 2 and this is a real axis, right, they all lie here. U1 is 2 exactly, and U2, U3, U4, dot, 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 they all are here. None of them are here. So root 2 minus 1 lies all the way down here. Right, it's below 1 actually. Root 2 minus 1 somewhere here. And when you take any epsilon neighborhood of root 2 minus 1, there is no element of the sequence. So definitely cannot be a limit point, because that defies the definition of the limit point of a sequential limit, right? So what we need to do is that we need to say that the function is the limit of the sequence is root 2 plus 1. Because root 2 plus 1 is definitely greater than 2. It's close to what? 2.414, right? It's close to that. So the limit n tends to infinity un equals root 2 plus 1. It's proved. Thank you for watching. I'll see you next time. If you have any questions, please feel free to comment and I will definitely answer you. Thank you.